And is my screen
Yes.
visible?
Yes.
Yeah.
Okay, thank you. So previous session we saw classification problem where in first problem we were classifying handwritten digit and we were solving a multi-class classification problem, right? Because there are 10 classes in that problem, right? And we are predicting 1 out of 10 classes. Yes. So handwritten digit classifier we are training, and there are 10 categories of handwritten digit from digit 0 to digit 9, right? And we also saw one binary classification example where we are predicting 5 versus not 5 class, right? So one category is whether a given for the given image category is 5, the other category is not 5, right? Okay. So and so what we did in previous session, we divided data in two parts: training part, test part. Training part we use for training our model, and we evaluate performance of our model using test data, right? Yes. So for this classifier, where we are predicting only two classes, 5 versus not 5, the data set is skewed because here digit 5 we are having in minority and not 5 digit we are having in majority. So most of the images belongs to the second category, not 5 image, right? And only few images belongs to, or roughly 10% of images belongs to digit 5, right? So in that case, if we use classifier, uh, so for example, AGD classifier, or you can take any other classifier, but then we cannot use accuracy as a measure because in that case, since we have skewed data set or we are having some classes in majority, some classes in minority, so accuracy in that case is not a good measure of performance. So what we can do if we have skewed distributions, skewed class distributions, or when we have classes, some classes we are having in minority, some classes we are having in majority, then we should use some other performance measure such as precision recall, F1 score, that we will see in today's session, right? So accuracy we have discussed. How can we use accuracy to measure performance of any machine learning model, right? Okay. Yes. So we also saw if we use HDD classifier to classify 5 versus not 5 category, then uh, we got 95% accuracy, right? But even if we use a dumb classifier where we are always predicting not 5 class, then also in that case we were getting 90% accuracy, and 90% is again a very high number, right? So clearly here accuracy is not a good performance measure when we have biased distributions, when we have major some classes in majority, some classes we are having in minority, then accuracy is not a good performance measure, right? Okay. Yes. So then what we should choose as a performance measure? In that case, what we will do, we will create a confusion metric. So a confusion metric. So for example, let's say if we are solving a binary classification problem, in binary classification problem, we only have two classes, right? So in that case, this confusion matrix, size of this confusion matrix is 2 by 2 because there are only two categories. If we are having uh, C classes, or if we are solving a multi-class classification problem, in that case, this confusion matrix size will be C by C, right? Or we can have two types of method there if we have multi-class classification problem. Either we can create a C by C matrix, or we can create 2 by 2 matrix for each class. So suppose, for example, if there are capital C classes, either we can create a C by C confusion matrix, or we can create 2 by 2 confusion matrix for each class. So class 1 we will create 2 by 2, class 2 we will create 2 by 2. Okay. So let's first discuss confusion matrix for binary classification case where we are having two classes. So in case of two classes, we will have a 2 by 2 matrix, right? So this side we will write actual predictions, and this side we will write model predictions given by the model, right? And here we are writing actual predictions. Okay, so this is the true output, yes output, and this is the second is the no output. So now this problem can be any binary problem, binary classification problem. So for example, here you can write digit 5, and this side you can write not 5, right? So there can be two cases because we are solving a binary classification problem, right? So 5 versus not 5. So this side we can write not 5. Or let's say we are detecting cancer. So here on yes side you can write true, and no side you can write false, right? If cancer is true, then we will write here. If let's say it is false, then we will write here, right? Okay, so in binary case there can be two cases, true or false, yes or no, or 1 or 0, right? So we only have two cases, so we will write those cases here. And model predicted values we will write here, horizontal side, right? Okay. So this is the case when the output, actual output is yes. This is the case where actual output is no. Here, model is telling us that for that input output is yes. And this case, model is telling the output is no, right? Okay, so we can have total four cases, right? When actual output is yes, and model is also saying yes, right? So actual output is yes, and model is also saying yes. And this case is called true positive, right? So true positive means model is saying positive, model is saying the correct thing, right? So actual output is yes, and model is also saying yes. So 620 examples are there where model is also saying yes and actual output is also yes, or model is saying true and actual output is also true, right? So this case is called true positive because model is truly positive here, right? Okay, the second case is false negative, where the actual output is yes and model is predicting no, right? So total 380 cases are there where the actual output is yes and the model prediction is no. So this case is called false negative, right? Because here the prediction of model is wrong, right? Actual was yes, but model is predicting no, right? Okay, the third case is where actual output is no, but model is predicting yes, right? So in this case is called false positive because model is false positive here, right? Model is telling yes, but actually it is no, right? Okay, the fourth case is when actual output is no and model is also saying no, right? So in this case also model is correct. So this case is called true negative, right? Because model is negative and model is true, right? So this so here 8820 times model is correctly predicting no. 620 times model is correctly predicting yes, right? So here, can I say that these two, 620 and 8820 are the cases where model is not making any mistake, right? Okay, so given this confusion matrix, can you tell me the total number of samples in our data set?
It will be addition of all four.
Yes, it will be the addition of all four, which means 620 plus 380 plus 180 plus 8820 is the total number of sample in our data set, right? Okay, and all these cases are mutually exclusive, which means if we have any sample in this category, the same sample cannot be there in other three categories, right? Okay, and how many times model is predicting the correct value?
True positive or true negative times.
Yes, so 620 plus 8820 times model is predicting the correct output, right?
Yeah.
Here also model is true, and this time also model is true. So now, given this confusion metric, can you calculate the accuracy of this model?
Sorry, can you repeat the question?
Given this confusion matrix, can we calculate accuracy of this model?
94.4%.
Yes, yes.
The true
So
ones divided by total.
yes, yes. So it will be the sum of diagonal elements divided by sum of all values, right? So sum of diagonal values plus
All
sum
of
of all values, right? Okay, so this is the accuracy that you can easily calculate. But now we will define two more terms, precision and recall. And precision recall will depend on these four values: true positive, false positive, and true negative, right? Okay, so this is the example, and here I'm showing the same things, right? So here I'm writing note false case, and this side I'm writing true case, right? So we can exchange these two. So here in this matrix, we are writing yes or no or one, or this side yes. For yes you can write one, for no we can write zero, right? So yes or no, one or zero, or you can say true or false, right? And we can also exchange this. So it's not like that first row has to be yes. First row we can also write no. So we can also write this matrix in this value. So for example, no yes, no yes, right? So we can also do this. So in the second case, we are doing the same. Here first we are writing no, and then yes, false or true, or you can say zero or one, right? Because we are doing a binary classification problem. So these are the two cases. So as you can see here, actual output is not 5, and model is also predicting not 5. So these are the true negative cases where model is predicting correctly, right? So this is true negative. So here we have true negative in the last cell, because the second row and second column we are writing no no, but in this case we are first column and first row we are writing no no, right? So this true negative uh, uh, we are writing here on the first cell, right? Okay, so this is the true negative case where actual is no and model is also predicting no, right? Similarly, yes. So, for example, let's say we are given a digit 7 image and model is predicting not 5, right? Yes. The second case is false positive. So here the actual output is not 5 and model is also predicting not 5. Okay. Uh, yes, yes. Okay. Am I audible?
yes.
Okay, okay. Yes. So this is the second case where digit is not 5, but model is saying 5, right? So this case is false positive, right? And the example is when we have digit 7 image and model is predicting uh, 5, digit 5, right? So model is predicting here wrong. right? Okay. The third case is where we are having 5-digit image, but model is telling not 5, right? So this case is false negative. And this is the example where input we are having digit 5 image, but model is predicting not 5 class, right? The other case is true positive, where actually we are having digit 5 image and model is also predicting digit 5 image, right? So these are the 4 cases. Now we will define precision and recall that and we will use these 4 terms: true negative, false negative, and true positive, right? Okay, so confusion matrix means we are creating the matrix that I have just discussed, 2 by 2 matrix for binary case and C by C matrix for multi-class problem. So for binary we will create a 2 by 2 matrix, right? Now we will define precision and recall. Okay, so precision means lack of mistakes, right? So how precise we are in predicting the correct output, right? So precision means lack of mistakes. Model Ideally model should not make any mistake, right? So what we want? We want high precision. High precision means model is not making any mistake, right? Yes. So precision means what proportion of images that were classified as not 5 were actually 5, right? So precision is what proportion of images that were classified as not 5 were actually 5, right? So precision you can define true positive divided by true positive plus false positive, right? Which means true positive, this cell, divided by true positive plus false positive, right? Okay, so this side we are having the total number of cases where model is predicting true, model is predicting 5, right? Or model is predicting yes. Because this column, because this side we are writing model predicted value and this side we are writing actual value. So here row will give us the actual data, actual values, and the column will give us the um, model predicted values, right? So this column, second column, is the total number of cases where model is predicting true, model is predicting 5. First column will give us the total number of cases where model is predicting negative, model is predicting false, model is predicting not 5, right? Similarly, this first row, if you sum these two cell, the first row, we will get the cases where the actual output is false, actual output is no, or actual output is not 5, right? Similarly, the second row will, if you calculate these two cells, the second row, we will get the actual cases where the output is yes, right? Or the digit is 5 in this case, right? Okay, so precision, what we are doing in calculating precision, we are calculating this ratio. True positive, this cell divided by sum of these two cells, right? True positive plus false positive. Okay, so in numerator, we are having the cases where model is correctly predicting uh, class 5. Model is correctly predicting uh, true answer, right? This cell divided by the total number of cases where model is predicting true, where model is predicting yes, right? So in this case, this the prediction of 5 means uh, prediction of true value or prediction of yes, right? And not 5 means uh, false case or no case, right? Okay. So that's why here I have written what proportion of images that were classified as 5 were actually 5, right? Okay, so any doubt in precision? So here in this example, can you calculate the precision? So here precision will be 3 divided by 4, right? Because 3 time model is predicting yes divided by total number of time model is predicting yes, right? So 3 time it is predicting true value, 3 time it is predicting 5 divided by 3 plus 1, right? Because in this case we only have one image. Here we are predicting 3 images. This cell we are predicting uh, 5 images, and this cell we are having 2 data points, 2 handwritten images, right? So here precision is 3 divided by 3 plus 1, right? Any doubt here in precision? Precision is
One,
yes, yes, yes,
yeah, one quick question. So what we calculated now was precision for this model to predict 5,
yes.
right? But if you want to, I mean, can we have precision for the model itself, which means that, it has to be for all the numbers. So how do we calculate that, or we can't calculate that?
No, no, no. So here we are calculating precision for model. Means whenever model is telling true, whenever model is predicting yes answer or true answer, or in this case digit 5 answer, then what are the chances that the model is correct?
Okay, but these numbers, I mean, the numbers which you are seeing right now, true negative as 5, false positive
Mhm,
as 1, and so on, this is
mhm,
only for one use case of 5, right?
mhm,
Similarly, if this model which we are generating is to predict numbers, right?
mhm.
It will have similar numbers for 1, 2, 3, 4, and other numbers also, right? Other 9
Yes,
numbers.
yes, 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 yes.
So how
So
will you,
mhm,
sorry, go ahead.
yes. So in that case, what we can create, either we can create a C by C matrix, because let's say if we are predicting 10 classes, 10 categories, 0 to 10, 0 to 9. So in that case, either we can create a 10 by 10 matrix, or what we can create a separate 2 by 2 matrix for each category. So for example, for digit 0, we can create one such matrix, digit 0 versus not 0. Then for digit 1, we can write digit 1 versus not 1. Likewise, we can create digit 9 versus not 9. So in that case, we will have 2 by 2 confusion matrix, and we will have 10 such 2 by 2 confusion matrix, each for one class, right? So digit 0, we will have one confusion matrix, digit 1, we will have one confusion matrix. So like that, we will create total 10 confusion matrices of size 2 by 2, right?
Yeah, okay. Uh, so then how will we, based on those 10 metrics, how will we calculate precision for the entire model, or we can't do that? We'll have to do precision for each confusion matrix.
Yes, yes. So we will create in that case precision for output 1, precision for output 2. Then finally we can combine all these precision to get the final value, so that we can get how many times model is predicting correctly, right? So this precision is related to the model. So whenever model is saying yes, whenever model is saying true, whenever model is predicting the true answer, what are the chances that model is correct, right? Because precision means lack of mistakes, right? So
Okay,
here model
so
is yes.
so basically we'll just add up the precision for each of the numbers, and that will be the total precision for the model.
Yes, yes. So I will discuss that
Okay.
case later,
Oh,
but
okay.
we will calculate precisions, and then we will calculate recall for each category, and then we will. So it also depends on what classes we are focusing, right? So for example, if we have majority classes, if we have minority classes, right? So
Oh,
so
okay.
it's yes, yes. So and it's also not like that. We cannot use accuracy here, right? So
Hmm.
we calculate accuracy also. We will calculate precision also. We will calculate recall also. So sometimes what we do, we calculate multiple performance measure and then we will decide, right?
Okay.
So it's
Okay.
not like that by just using one measure, we can decide, right? Okay, so here the precision is 3 out of 4 or 3 divided by 4, right? So similarly, we have one more term, recall, and recall means remember something learned in past, right? So here for the recall, we will consider these two cells, right? So recall is true positive divided by true positive plus false negative, right? Which means what proportion of images that were actually 5 were predicted as class 5, right? So if you sum these two cells, you will we will get the total number of true cases, total number of in this case total number of digits, handwritten digit, uh, handwritten 5 digit, right? Okay. So if we sum these two cases, we will get total number of actual true cases, right? And this cell is is giving us the total number of cases where model is true positive, right? So if we divide true positive divided by these two cells, we will get a recall. So recall is a ratio where uh, we are calculating this recall using true positive and false negative, right? So recall is true positive divided by true positive plus false negative. And what this ratio will tell us, this ratio means what proportion of images that were actually five were predicted as class 5 by our model, right? So in recall, we are focusing on uh, remembering something, right? Because actually these are the total number of cases, actual cases, but our model is only able to capture these many cases, right? So it only remember only these types of cases. So total there are 5 true cases, right? Because 3 cases are here, 2 cases are here. So total number of cases, true cases are here is 5, right? Out of which only 3 time model is predicting uh, true, right? So, and 2 time it is not able to remember its class, right? So, which means in recall means remembering something learned in the past, right? And the precision is lack of mistakes, which means when model is saying true, how many times this model is correct, right? So as you can see here, 4 time model is saying yes, model is saying true, but only 3 time model is correct. So here precision is 3 divided by 4 and recall is uh, total number of true cases here are 3 plus 2 5. So recall is 3 divided by 5, right? So any doubt in precision and recall? Okay.
Are both these measures equally important, or do we attach more importance to precision or one of these?
Yeah, so it depends on problem. Sometimes we will give more weightage to precision, sometimes we will give more weightage to recall, and sometimes we will give equal weightage to both precision and recall.
Can
Right?
you provide an example for?
Yes, yes. So I will provide example later. But here also, if you use the definition of precision and recall, then we can get a idea where we should use precision and where we should use recall, right? So, for example, in precision, what exactly we are interested in? If model is saying yes, it has to be correct. So 100% precision means, so let's say precision is 100%, precision is 1, then we will not have any value for this cell. For this particular, for this cell, we will not have any value, right? Which means, sorry, which means whenever model is saying yes, it is correct, right? Whenever our model is telling true, model is correct if precision is 1, right? So it may here possible that model is only 50 times model is saying yes, right? It may possible that we are having so as you can see here, let's say this cell we don't have any value, right? So this cell we don't have any value. So in this case, what will be our precision? 3 divided by 3 plus 0. Assume in the cell we have 0 value, right? But precision is 1, which does not mean that model can capture all true cases. As you can see here, total there are 5 true cases, 3 cases are here and 2 cases are here, but model is only able to capture 3 cases. Model is only able to capture some positive cases. But whenever model is saying yes, whenever model is saying true, model is 100% correct, right? So can you give me now the example where precision is more important? So in let's say here, if precision for this cell, if we have any 0 value, right? We don't have any sample for this cell, then precision will be 100%. Precision will be 1, but precision 1 does not ensure that our model is able to capture all true cases, right? Maybe model is capturing some positive cases, but whenever model is saying true, model is 100% correct. So can you imagine the case where this precision is more important?
When cancer detection, say for cancer detection, if says model says yes, if that is correct.
Yes, yes. So if we are detecting any rare digit, then yes, but we will there consider both precision and recall, right?
I think in case of this high risk or cancer detection, right, recall should be more important.
Okay. Any other example? So suppose let's say you are building a system where you are recommending, let's say, video for kids, right? So some video you will recommend as a safe video, and some video you will recommend not safe for kids, right? So there, what we want, high precision or high recall? For a given video, our model will recommend is it safe? So let's say for the given video is safe for kid or not, right? So here again we are doing binary classification problem, safe versus not safe, right?
Precision
So
is more important.
yes, yes. So in this case, what we want, high precision, right? Because let's say if there are 10 videos and 5 videos are safe and 5 videos are not safe, and our model is only able to capture 2 safe video, but since model is 100% correct, so if model is saying any video safe, the video will be actually safe for kids, right? So in this case, we don't want recall, we only want precision, right? Because whenever model is saying that video is safe, it has to be the same, right? And we don't want model to capture all safe, true safe cases, right? So in this case, we want high precision, right? So don't worry, I will discuss these cases later, right? Okay. So now we have two performance metrics, precision and recall. But as I said, sometimes we need both precision and recall, and we want to give equal weightage to both precision and recall. Then we will consider F1 score. So F1 score is nothing but a harmonic mean of precision and recall, right? So F1 score, okay, so let me show you the formula for precision and recall. Okay, yes. So F1 score is a harmonic mean of precision and recall, right? So harmonic means here you can write 1 by precision plus 1 by recall divided by 2 is equal to you will get 1 by F1, right? So this is called harmonic mean, right? So whenever we calculate harmonic mean between two values, harmonic mean is maximum when both values are nearly equal, right? So this harmonic mean or F1 score we can maximize only when precision and recall are nearly same, right? If precision is, let's say, high or recall is low, in that case, F1 score will be low. Or let's say if recall is high, precision is low, then also F1 score will be low, right? So since F1 score is a harmonic mean of precision and recall, which can only maximize when both precision and recall are nearly the same, right? So here, if you want to maximize F1 score, then what exactly we are doing? We are giving equal weightage to both precision and recall, right? Okay. Yes. So here I am taking another example and creating confusion matrix of 2 by 2, and here we are our model is predicting cancer. Someone has cancer or not. So again we are solving a binary classification problem, cancer versus not cancer, right? So here we will create 2 by 2 matrix, no, yes, no, yes, right? Actual cases and the predicted cases. So in this case, can you calculate the precision? What will be our precision? So precision will be the correct prediction divided by total number of true predictions given by the model, right? So correct predictions by model is 100 divided by 100 plus 10. So here we will get 0.91 precision, right? Similarly, if you want to calculate recall will be 100 divided by 100 plus 5, right? So precision will be 100 divided by 100 plus 5, right? So 0.95 is the precision, right? Okay. Now let's discuss the code for calculating confusion matrix. So if we want to calculate this confusion matrix, what we want? We want these four values, right? So these four values, after getting these four values, we will calculate confusion matrix, and then we can calculate precision and recall ratio, right? Okay. So for calculating confusion matrix, we will create package scikit-learn.matrices. We will import confusion matrix, and in the confusion matrix, we will pass the predicted output, model predicted output, and actual output. So let's say if we are calculating confusion matrix for 5 detector, 5 versus not 5. So we are creating a model that detects 5 versus not 5. So here we will pass y train 5 means the predictions given by the model, and y train pred means the actual predictions, right? So here we will pass the model predictions comma actual prediction, and it will create the confusion matrix of 2 by 2, right? Okay, so here first we are calculating the model, right? So if we use HGD model, so we are predicting, we are using cross validation to calculate the best model, right? So HGD underscore CLF is the model, right? X underscore train is the training data, Y underscore train underscore 5 is the output, right? And cross validation 3 means we are doing threefold cross validation, right? So it will select the best model, and using that best model, we will create this confusion matrix of size 2 by 2, right? Okay. Now, if we want to get the precision, we will import precision underscore score, recall underscore score to get precision and recall, right? So if you want to calculate, so either using this matrix directly using formula, you can calculate precision or recall, or using this method also you can create precision and recall, right? So precision underscore score, here we will mention the model outputs comma actual output and you will get the precision score, right? Similarly, to get the recall score, uh, again you will use recall underscore score method, and we will pass here the model predicted output comma actual output, and this function call, using this function we will get the recall, right? Okay. So if we calculate precision and recall for the same model 5 detector, now this time we are getting 83% precision or 0.83 precision and 0.65 recall, right? Okay. So for the same detector, if we use sorry, classification as a as a performance matrix, then we were getting 95% classification accuracy, right? 95% classification accuracy for the same 5-digit classifier, right? So here we are getting a very good accuracy, 95% accuracy. But when you calculate precision and recall, yes, then we are getting 0.83 precision and 0.65 recall, right? Okay. So now, can you justify in this case why we are getting high precision and low recall? What we are predicting here, digit 5, right? So for not 5, we are having 90% of data, and for 5 digit, we are only having 10% of data, right? So this model is correct only 83% of time, right? Which means if model is predicting digit 5, our model is 83% correct 83% of time, right? But our model can only detect 65% of true cases, only 65% of true cases, and remaining 45% sorry, remaining 35% cases, model is not able to detect, right? So only 65% of cases, model is true cases, model is able to detect, and out of 65% cases, model is only correct by 83% of time, right? So this is meaning by precision and recall, right? Okay. F1 score, I have already discussed. So we will use F1 score when we want to give equal weightage to precision and recall, right? So precision, F1 score is a single matrix which combines both precision and recall. And this single matrix is called the F1 score, which is nothing but the harmonic mean of precision and recall. And F1 score is maximum when F1 score, we can get the maximum value when precision and recall are nearly equal, right? Okay. So F1 score is high when both precision and recall are almost similar. Now, how can we get precision score? So for that, we will use F1 underscore score function. So we will import F1 underscore score from scikit-learn matrix A, and again we will pass here the model predicted value comma actual output, right? So y train underscore pred is the actual output, and this first parameter is nothing but the model predicted output, right? And it will create, it will calculate F1 score, right? Okay. Yeah. So now you may think that we can achieve both high precision and high recall for a model, but unfortunately, there exists a trade-off between precision and recall, right? So if you try to increase precision, recall will reduce, or if we try to increase recall, precision will reduce, right? So we cannot increase both, we cannot achieve both high precision and high recall at the same time, right? Because uh, we have trade-off between precision and recall, right? If we try to increase precision, recall will decrease. If we try to increase recall, precision will decrease, right? Okay. So there exists a trade-off between precision and recall. So both precision and recall we cannot achieve high, right? Okay. Now to better understand this trade-off, let's take HGD classifier. So in HGD classifier, we are predicting 5 digit, right? So here model is predicting 5 versus not 5. So we are solving a binary classification task, and model is predicting digit 5 versus not 5, right? So for this classification task, model is calculating score, right? And then we will use some score to predict its class, right? So given this image, machine learning model will calculate one score, and we will use some threshold. If score is greater than threshold, then one class; if not, then the other class, right? So here this threshold is decided by the classification algorithm, right? So yes, so here we are doing binary classification using HGD classifier, right? So as you can see, if point lies above this line, if point lies above this boundary, then its class is 0, else uh, its class is 1, right? So here class we are deciding by using this line, right? Using this boundary. So if you put this point here in this line, what value we will get here? Greater than 0, right? Because all these points lies above this line. So if you put any value here in this equation of line, we will get a positive value, right? So for example, let's say the equation of this line is 2x plus 3y, right? 2x plus 3y is equal to 0. And let's say here we are having x feature, y feature, right? So let's say 2x plus 3y is equal to 0. And let's say the here we are having some x1 comma y1. So if you put x1 comma y1 here in this equation of line, 3x plus 4y, so you will put if 3x1 plus 4y1, you will get a positive value, right? If point lies above this line, then we will get the 0 value, right? So if point lies above this line, we will get a positive score. If point lies below this line, we will get a negative score. So here, this SGD classifier is in this case is nothing but the line, and the score is we are calculating, and if that score is positive greater than 0, which means class 0. If that score is less than 0, which means class 1, right? So in this case, we are using threshold, and our threshold is 0, right? Because if score is greater than 0, which means class 0, if score is less than 0, means point lies below this line, then class is 1, right? Now, if you shift this line, let's say if you are shifting this line, let's say towards this direction, towards upward direction, if you shift this line, then what will happen? Which means we are increasing our threshold, right? So it will not classify some class 0 point correctly, and in fact it will classify some class 0 points as class 1 point, right? If you shift this line in upward direction. Similarly, if you shift this line in downward direction, which means some class 1 example will be misclassified as class 0 examples, right? If you shift this line downward, then some class 1 example now will be misclassified as class 0 example. And what exactly we are doing here? We are decreasing threshold, right? Because if we use the same line, which means here the threshold is 0. If point lies above this line, which means class 0, below this line, which means class 1, right? Yes. So in this model is calculating some score. We are using some threshold. If score is greater than threshold, then positive class, else negative class. And its threshold is decided by the algorithm, right? Okay. So using scikit-learn, we can calculate this score given by the model, right? So how can we calculate these scores? So for that, so this SGT underscore CLF is nothing but our model, right? We have trained this model SGT underscore CLF. So if you write SGT underscore CLF dot decision underscore function, you will get the score for any particular input, right? So given this image, it will give us the score, right? And how internally this score model is calculating? In model, it will fit this input, and you will get the value. So for example, let's say equation of line is in simple case, let's take model is the line. So 2x plus 3y, right? So it will put that x1 y1 point to x1 plus 3y1, and you will get that value as a score, right? So here, if we want to calculate score, we will use decision underscore function, right? Okay. Now this score is positive, which means the positive class. If score is less than 0, which means the other class, right? So in this case, what threshold we are using? Threshold we are using 0, right? If score is positive, greater than 0, means positive. If score is less than 0, which means negative class, right? Okay. So for 5 and not 5 classifier, for this binary classifier, threshold is 0, and if if threshold is 0, and if score is greater than 0, which means true class, positive class. If score is less than 0, then the negative class, right? So since in this case we are getting a score that is greater than 0, which means we are getting the true output predicted by model, right?
Sorry.
Yes.
How is this threshold being determined? How do you confirm that 0 is the threshold?
No. So for most of the cases, 0 is the threshold, but we can change this threshold. If we change this threshold, model will change, right?
So this SGD classifier is showed one line, right?
Yeah. So SGD classifier, if uh, uh, we are learning a linear model. In case of linear model, that model can be line, can be plane, can be hyperplane, depending upon the number of features. So for example, if we are using 2 feature data, if we are using data where we are only having 2 features, in that case, it will learn a line. If we are using 3 features, then it will learn a plane, because x, y, z, if we have 3 features x, y, z, it will learn a plane. If we are if we are having more than 3 features in our data point, so for example 30 features we are having, or let's say 40 features we are having, in that case it will learn a hyperplane, right?
Got it. But what is that threshold in that SGD classifier? That
0. Default value is 0.
Okay, default value 0 means you don't have any, that dotted line is not there. It's the same line, right? That's what.
Yes. But we can change this threshold value, right? So for example, here we can write threshold is equal to 5. So whenever the score given by model is greater than 5, it will consider that input as a true. Else it will consider that. So let's say if score is less than 5, and if threshold is 5, then model will predict false, right?
Score is the FN score, you're saying?
Sorry.
The score means it is the FN score?
No. This score means the model predicted score, right? So for example, let's say here, if model is this line, yes, if model is this line, and assume equation of this line is, let's say 2x plus 3y, 2x plus 3y. So when you put this particular point x1 y1 here, 2x1 plus 3y1, you will get one score. So this is our score in this case, right? When we put that particular input in our model, then what model is calculating? Because machine learning model will always take numerical data as input and will give us the numerical value as output, right? So when we put x1 comma y1, or in this simple case this coordinate of this point here in this line, what real value we will get in output? So that real value is our score in this case, right? So score means when you put this particular input, some digit in to our model, what value what value we will get using this model, right? So this is the value. Then we will use some threshold. If this score is greater than something, then one class. If not, then the other class. Because what we want in output, we don't want real output, real value in output. We want class in output. We want two classes in output, right? True and false. So
SGD classifier can be used only for binary classification?
no. SGD we can use to solve for regression also, right? So SGD is not a classification algorithm. SGD you can think like a, a learning algorithm, and using SGD algorithm we can learn a classification. We can solve a classification problem. We can solve a regression problem. We can solve a multi-class classification problem, right?
So in multi-class, if that is a multi-class, then how will we divide using the score?
So that part I will discuss later, because in multi-class we will get a vector in output, right? Now, sometimes, let's say if that vector is a sum of probabilities, then that vector sums to 1, and we will predict its class whenever. So let's say for third class, if we are getting a highest probability, then we will predict its class as 3, right? Let's say for the second class, if the number that we are getting is the highest, then its class is 2, right? So in multi-class, so for other models, we will have other. So it's not true for always, but yes, in some models they uses the probabilities number, right? So if we are having 10 classes, we will get 10 probabilities number in output that sums to 1. And let's say for any particular ith class, if that probability is maximum, then we will predict class as I, right? And sometimes we use binary classifiers, multiple binary classifiers to predict a multi-class classification problem. So what we can do there, we can create multiple classifiers. So let's say to solve 10 class classification problem, we can take 10 choose 2 10 C2 binary classifier, and also we can solve that problem. So that approach is called one versus rest or one versus all scheme, and that I will discuss later, right? Okay. So here model output depends on this value of threshold that we are choosing, right? Which means here for this particular image, model score is 2164.22, right? And if my threshold is 0, then model output is true. But let's say if my threshold is, let's say, 2500, if my threshold is 2500, then for the same input, now the model will predict false, right? Because model score is 2164.22 is greater than 2500, condition false, which means model will predict false, right? So model predictions will depend on this threshold. Okay, so now let me ask one question. If I increase this threshold value, then what will happen? If I increase this threshold, then
It will classify incorrectly.
yes, some 5 cases will be classified as not 5, right? Some 5 cases will be classified as not 5, right? So let's say if threshold is 8,000, if threshold is 8,000, for the same example, now it will predict false, right? Earlier, for the threshold 0, since this score is greater than 0, so model is predicting true. But let's say if threshold is 8,000, now this score is not greater than 8,000, which means now model is predicting false, right? So if you increase this threshold, some 5 cases will be classified as not 5, right? So yes. So in this case, if some 5 classes we are skipping, we are not able to detect 5 classes, because some 5 classes will be considered as not 5. So can I say that recall will decrease here if I increase threshold, right? Because what recall is capturing, how many times we are capturing 5 cases, true cases, right? So let's say if there are total 100 true cases and model is only predicting 80 times, which means recall is 80 divided by 100, right? So if some true cases, some 5 cases we are predicting as not 5, which means now model uh, model power of predicting 5 is it has been reduced, right? Because some 5 cases model is not able to capture, right? So it will decrease recall, right? Yes. So now what will happen? Some 5 cases will not be predicted. Some 5 cases will be predicted as not 5, right? So model will predict. So for example, let's say if you use very high threshold, if you use very high value for threshold, then maybe now let's say this 5 model may predict as not 5, right? So and that will reduce recall, right? Because now let's say one sample or two samples may go in this side, right? Because some 5 cases will be now predicted as not 5, right? So that will reduce recall. But if you are increasing threshold, we are increasing precision, right? Because we are using very high threshold. We are using very high threshold, which means if model is telling yes, if model is predicting 5, the probability of model being correct is now very high, right? Because we are using very high score. So this fact you can visualize using this diagram. Suppose if I shift this line in the upward direction, and if this the same model is saying class 0, which means the point being class 0 is now very high, right? So some class 0 point will be classified as class 1 point, but if model is saying class 0, then probability of being model being correct is very high, which means if you increase this threshold, if you shift this line towards upward, recall will decrease, but precision will increase, right? Because now in this case, since we are using a very high value for threshold, so if model is saying true, which means the chances of model being true is very high, right? Yes. So if we increase this threshold, recall will reduce, but at the same time, precision will increase, right? And vice versa. If you decrease this threshold, then recall will increase, but precision will reduce, right? So that's why we have a trade-off between precision and recall. If we increase precision, recall will reduce. If we increase recall, the precision will reduce, right? Okay. So what ideally we want? We want good precision and good recall, right? And for that we will use F1 score, because F1 score is maximum when both precision and recall are nearly equal, right? So here I am showing precision recall curve versus the number of thresholds, right? So here if you change, so let's say for one model we are using threshold 0, for other model let's say we are using 8,000 threshold, for some other model we are using 5,000 as a threshold, right? So if you change these threshold values, model will change, right? Because if you change this threshold value, so let's say in that line example, if you change this threshold, you will get a different line, right? Or if you shift that line upward or downward, you will get a new line, new model you will get, right? So for each threshold value, we will get a different model, right? So here we are choosing different values of threshold, and for each threshold value, we will get one model, and for that model, we will calculate precision and recall. So for example, for threshold 0, we will get one model, and for that model, we will calculate precision and recall. For let's say for some other threshold, we will get another model, and for that, we will calculate precision and recall. So if you change, if you plot threshold versus precision and recall values, you will get this type of curve. And here, one thing is clear that if we try to increase precision, recall will decrease. If we try to increase recall, precision will decrease, right? So we have inverse relationship between precision and recall. So what we want here, we want good precision and good recall, so that and for that we will use F1 score. So this is the value, this is the threshold value 0, where we are getting good precision and good recall, because both precision and recall are nearly same, and since both precision and recall are same, then we will get the high F1 score for this value, right? For threshold 0, we will get maximum F1 score, right? Because F1 score is nothing but the harmonic mean of precision and recall, and that can only maximize when both precision and recall are equal, right? And this is the point where precision and recall are equal, right? Okay, so here what we can do, we can use scikit-learn to plot these curves, precision recall curves, where on one axis we will consider several values of thresholds, and we will calculate precision and recall for each threshold, and we will plot, sorry, we will plot these curves, right? Now let's say we want high precision, we want 90% of precision, we will use this particular threshold, right? We will choose threshold to this value, because for this value we are getting 90% precision, right? And if you want high recall, then accordingly you will choose lower value of threshold, right? So depending upon our requirement, whether we want equal precision or equal recall, or we want high precision or we want high recall, we will choose one threshold, right? Okay, so just give me 2 minutes. I'm just coming.
Hello? Hello?
Yes, Deepak.
Is there a break?
Yeah, it is a kind
Yeah,
of break.
he just stepped away.
Okay.
Actually, I thought my network issue, I'm having network issue.
Right.
Hello?
Yes,
Am
sir.
I
Yes,
audible?
Professor Pravin. Yes, you're
Yes,
audible now.
Okay. Any doubt?
No. I thought,
Okay.
yeah.
So here, depending upon our requirement, whether we want high precision or high recall, or we want high F1 score, we will choose one threshold, right? So as you can see here, for this threshold value 0, we are getting equal value for both equal values, precision and for recall, right? So for threshold 0, F1 score will be maximum. For this particular threshold, we will get high precision, right? And for, let's say, for this particular threshold, we will get a high recall, right? So, and yes, we cannot achieve both high precision and high recall at the same time, right? When this precision is let's say very high, then recall is at that time low, right? And vice versa. Yes. So we can use scikit-learn to plot these precision recall curve. So for that, we will use decision underscore function, and we will compute uh, precision underscore recall underscore curve. This method we will use to get precision recall curve for all possible values of thresholds, right? Because we need several threshold values to plot this curve, right? So, and for each threshold value, we will compute precision and recall, and we will plot this precision recall curve, right? Okay. So here we are using cross validation to predict the best model, right? X train training data, Y train is the output. CV is equal to 3 means we are using threefold cross validation, and here we are using decision underscore function to decide the best model. So HGD underscore CLF is our model in this case, right? Now to plot this precision recall curve, we will pass here the model predicted output and the actual output. So we will pass here the actual output and the model output, and this precision recall curve will return us the three values: precision, recall, and the thresholds, right? So for one particular threshold, we will have one precision and one recall. For another threshold, we will get precision and recall, right? So likewise here, for each threshold, we will get two values, precision and recall, right? So this precision recall curve will return us, will return three values: precision, recall, and threshold. And these are the vectors, right? So we will get several precision values, several corresponding recall values, and several corresponding thresholds. So for each threshold, we will have one precision and one recall, right? Okay. So this is the code for plotting precision recall curve. So here we will pass these three vectors: precision vector, recall vector, and the corresponding threshold vector, right? And we will plot, so x-axis, what we want, x-axis, we want threshold. So here we are writing plt dot x label. So here we are using Matplotlib, right? So plt is a short form for Matplotlib, right? So, and yes, we have already used this short form several times, right? So x-axis we are using threshold, and then here we are defining ranges. So x-axis, what we want, range from -5,000 to +5,000. Y-axis we want 0 to 1 range, right? And figure size is 8 by 4, right? Width comma height. So here we will mention here width comma height. And this side we are writing plt dot plot. Here we will pass threshold values, x values, comma y values. And here I'm writing a colon -1, because in precision we will get one extra value. Similarly, in recall we will get one extra value. So we don't want last value, because last value is the extra value here, right? So if you call this function, if you call this precision recall curve, suppose you are getting 10 thresholds. So here for threshold, we will get a vector of size 10, right? But for precision and recall, we will get 11 size vector, right? There will be 11 elements in precision and recall for the 10 threshold. So one last value here is the extra value, right? Which is nothing but the 1 value and 0 value, maximum value of precision and recall. So 1 comma 0. So that value we will always get extra, and we don't want that extra value. So for that, here we are writing colon -1, which means we are taking all values except the last value, right? Which means from 1 to 10 we are considering, 11th we are neglecting because we only have 10 threshold values. So that's why here we are writing colon -1 for precision and for the recall, right? Because we don't want to consider the last value, last element of that vector, right? And we only want values up to second last value, right? So threshold, comma, yes.
I didn't get that. Maybe there was a
Mhm.
glitch in my network. So why is that last value neglected from this vector?
Because for the last value, it will always always give us the extreme values 1, 0, right? Precision in 1, recall is 0.
Oh, okay.
Yes, yes. And
Sir,
so,
extreme because of it's a sorted one.
yes, yes. So here what will happen if you call this function precision underscore recall underscore curve? Okay, let me show you in Jupyter notebook if I have. Okay, so yes, yes, yes. So if you call if you call this function precision underscore recall underscore curve, we will get three values: precision value, recall value, and threshold value. So as you can see here, when we are increasing the threshold, precision, this recall values is reducing, precision will increase, and threshold will increase, right? So for example, let's say if we have 10 values of threshold, there will be 10 corresponding recall and 10 corresponding precision, right? And the 11th value in precision recall will be, so for example, here in precision, the 11th value will be 1, and for recall, the 11th value will be 0. So we don't want that extra value, right? So that's why we are not considering the last, right? So if you call this precision recall curve function, we will get threshold values and corresponding recall values, corresponding precision value, and we will get one extra precision and recall value. And in this case, the extra precision will be 1 and extra recall will be 0, right? Yes. So we don't want that extra value. So therefore, here we are selecting values up to second last value, right? Okay. So x-axis we are here using threshold. Y-axis we want to plot precision. Similarly, in the same figure, we also want to plot recall. So here we are writing threshold comma recall, right? So we will get this plot finally, right? So x-axis we are using threshold, y-axis we are plotting precision and recall both, right? So that's why here we are writing x-axis we are writing a threshold, then precision, threshold, then recall, right? And this is the range. X-axis minus 5,000 to 5,000, y-axis 0 to 1, right? So x-axis minus 5 to plus 5,000, y-axis 0 to 1, right? Yes. So sometimes we want, let's say, high precision. Then using this precision recall curve, we will choose corresponding suitable threshold, right? Because for each threshold, we will get some precision and some recall value, right? So now, how can we choose the threshold? So we can also choose threshold. So here, let's say if we want 90% precision, we want 0.9 precision, right? So so here since the precision is high, so therefore recall will be low, right? So it's not like that we will get high precision and high recall. We can achieve both high precision and high recall. But yes, let's say it's a need of our problem that we want high precision. So we want to build a classifier with 0.9 precision or 90% of precision. Then how can we achieve this 95% precision? We have to select threshold. For that particular threshold, we will there will be 90% precision and some recall, right? But since we are only interested in high precision, so our goal here is to predict the threshold value, right, which is giving 0.9 precision, right? Okay. So for that, what we can do here, we can write here precision, right? Because if you call this function precision underscore recall underscore curve, we will get three vectors: one vector of precisions, one vector of recall, and one vector of thresholds, right? So we will get three vectors, and as you can see here, if thresholds are increasing, then recall precision will increase, and correspondingly the recall will decrease, right? So let's say in that vector, if thresholds are increasing, are arranged in the increasing order, then precision values will be increasing, and the recall value will decrease, right? Okay. So we will get these three vectors using this this function call. Okay. So now we will take that vector precision and we will apply this condition. Precision is greater than equal to 0.90 because what we want 90% precision, right? Okay. And here, as you can see, this precision values we are having an increasing trend, right? When we are increasing threshold values, when we increase threshold values, precision will increase and recall will decrease. So precision, we are having an increasing trend, right? Yes. So assume we are having this vector because if you call this function, we will get three vectors: precision, recall, and thresholds, right? Okay. Now we want to get threshold, which gives 90% prediction, right? So in precision, let's say we are having vectors 0.3% precision for some threshold, 0.4, 0.5, let's say, then 0.8, 0.9, then 0.92, right? So, and let's say 0.95, right? Now we are one side we are having vector, another side we are having scalar. So in Python, if you do this comparison, right? So you will get a vector of true and false, so, right? So it will apply this condition element wise, right? So for example, here for the first element, it will condition is false. So here you will get false, 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 false. Here you will get true and true, right? Okay. So this function, after doing this comparison, you will get a vector of true and false, right? Because here this condition is true. Precision is greater than equal to 0.90. Condition is true, so here you will get true. Here also condition is true, so again you will get true, right? And yes, we will have one more extra entry here, 1, right? So for that also we will get here true value, right? Now this function np dot argmax. So here np is nothing but the short form of numpy array, right? So we will import numpy array as np. So np is short form of numpy array. So this argmax function will return the position where this condition is first time true, right? So in programming language, we generally start index with 0, right? So this is index 0, index 1, index 2, index 3, index 4, index 4, index 5, and index 6, right? So this np.argmax will return the position where this condition is first time true. So where this condition is first time true? Here. This position we are having condition first time true. So it will return the position 4, right? So after calling this function np.argmax, we will get index 4, right? Now we will have corresponding threshold values, right? So for example, for threshold 1, we will have this value. Threshold 2, we will have 0.4 precision. For threshold 3, we will have this value, right? So for fourth index, we will get that threshold T4, right? So T1, T2, T3, T4, T5, right? So for that particular index, we will get the threshold value. And if we use this threshold value, we will get desired precision, right? Now, you can use that threshold to get the prediction, right? And this classifier will give a 90% prediction precision or 0.9 precision, right? So any doubt here in this code? Okay. And in fact, you can also verify it. So precision score, if you pass here the predicted value, model predicted value, and the actual value, you will get roughly 90% precision, 0.90 precision. And the corresponding recall is 0.43. Because precision is high, then recall will be low, right? Okay. And as I said, for each threshold, we will have one model, right? So for each threshold, we will have one model. So for this particular threshold, for this fourth index threshold, we will have one threshold value. And if you use that threshold value, you will get one model. And when you use that threshold, this is the model prediction, right? Because as I said, model will always predict score. Model will always predict score. If that score is greater than some threshold, then positive class. If that score is less than threshold, then negative class. So depending upon the value that we are choosing as a threshold, model prediction will change, right? So since we want 90% precision, so therefore we will choose here the threshold, the corresponding threshold. And if you use the threshold, you can create the model prediction, right? Model predictions are nothing but the score greater than equal to threshold, right? If model score is greater than threshold, which means positive class, here y train output we will get true value. If score is less than threshold, then model output will be false. So in output we will get a false value, right? So for this particular threshold, if you use model predictions, these are the model predictions and this is the actual data, then what precisions we are getting here? 90%, right? And the corresponding recall is, for the same threshold, corresponding recall is 0.43, right? Okay. So if you are building any machine learning model, and let's say if you want 99% of precision, then we should also ask at what recall, right? Because we have to consider both precision and recall, and depending upon our problem, sometimes we give more weightage to precision, sometimes we give more weightage to recall, or sometimes we give equal weightage to both precision and recall, and in that case we will use F1 score, right? So this example I have already discussed. Suppose if we are building a model to detect model is safe, to detect video is safe or not for kids, right? So if we have to build a model which detects if a given video is safe for kids or not, right? So in this case, we want, so let's take these examples. So for example, here we have some fighting is going on, right? So this video is not safe for kids. Similarly, yes, so this video is safe, again this video is not safe, this video is safe, right? So these are the ground truth, right? Actual outputs we are having. So in case of high precision, maybe our model is not able to capture all safe video, but if model is saying video is safe, then the very high chances are there that that video is actually safe. So in this case, we want high precision, right? We want high precision because model has to be the correct, right? If model is telling that the video is safe, it has to be the same, right? And yes, maybe it may skip uh, skip some safe video. It may classify some safe video as unsafe, But whenever model is telling that video is safe, it has to be the safe, right? So in this case, we want high precision, right? But since precision is high, recall will be low. But we don't care here recall, right? We only care about precision, right? So we would prefer a model which has high precision. It is okay if model reject many good videos, but keeps only recall, keeps only really safe one, right? What we want? We want uh, uh, if model is telling that this video is safe, it has to be the safe, right? Yes, so we want high precision, and since precision is high, recall will be low, right? Okay, now let's discuss another problem where we will give more weightage to recall, right? So say if we have to build a model which detects shoplifters on the basis of surveillance images. So in this case, if someone is marked as shoplifter, we will manually examine it, right? So let's say if our machine learning model detects shoplifter, then we will manually check it, right? So now for this problem, do we want high precision or we want high recall? Or we want equal precision, and we want to give equal precision to both recall and precision. What we want in this case? High precision or high recall, or equal weightage to both precision and recall?
Equal.
Okay. So let's say if you are giving equal weightage to precision and recall, then what will happen in that case? Model
There
may
is a
not.
possibility that
Yes.
there is a possibility that we miss out a shoplifter.
Yes, there is a possibility that we may miss out a shoplifter, and this case we do not want, right? Because if we miss that case, then damage is high, right? Damage is high. So we don't want this to be happen, right? So here, what uh, we want high recall. We want high detection of shoplifter cases. Even if precision is low, we want high recall, right? So we want to capture all true cases of shoplifters, and we do not want to miss any shoplifter case, right? And yes, since recall is high, then precision will be low. There will be several false alarm. There will be several false alarm, right? Because we are increasing recall, right? So whenever there is some positive case, something wrong is happening, then model will detect all such cases, right? But if model is saying that yes, it is something wrong, some wrong is happening, then chances of being model correct is very less, right? But this case we don't care because we will examine this case manually, right? Yes.
The quiz has started. The time has started for quiz.
Okay. Sorry. So yes. Okay, so this example I will discuss in the next session, and then we will see ROC curve. Okay.